Next topic is defects in solids. So you know about crystalline solids. So in crystalline solids, all the atoms, ions or molecules which are called particles, they are arranged in a regular order like this. Okay. So with the regular orderly arrangement of atoms or ions, this type of crystal is called perfect crystal. Okay. If any deviation takes place regarding the order, any disturbance takes place regarding the order, that crystal becomes imperfect. So, imperfection or defect that arises due to the disturbance in the regular arrangement of the atoms. Regular orderly arrangement of the atoms or particles or ions. Okay. So this type of crystal now is called imperfected crystal or defected crystal. Okay. So defects in solids, that is in two types again. One is intrinsic defect and another one is extrinsic defect. Okay. So defects are in two types. Number one, intrinsic defect. So intrinsic defect, it is generally present in pure crystals. Next, second one is extrinsic defect, generally present in impure crystals. Okay. So these are the general types of defects. Intrinsic defect, extrinsic defect. Intrinsic defect that is present in pure crystals, whereas extrinsic defect present in impure crystal. So here defect may arise at the lattice point, around the lattice point or throughout the row of the lattice point, throughout this line. Okay. So basing upon this, again defects are in two types, point defects and line defects. Okay. So depending upon the defect, nature of the defect. So two types of defects are there. One is point defect, another one is line defect. Point defect arises around the lattice point, particular lattice point. And the line defect arises throughout the row of the lattice point. Okay. So in pure crystals and impure crystals, we observe two types of defects. Okay. So defects may be two types depending on its nature. Number one, point defect. Okay. So point defect arises around lattice point, around a particular point. Okay. Then line defect. So line defect arises throughout the row of line, throughout the row of the lattice points. Okay. Arises through the row of lattice points. Okay. So basing upon the nature of defect, two types, point defect and line defect. Point defect arises around the lattice point and a line defect arises that throughout the row of the lattice points. Okay. Then coming to point defect. point defect again in three types: stoichiometric defects, non-stoichiometric defects, and impurity defects. Okay, so point defects are in three types. Okay, number one, stoichiometric defects. Number two, non-stoichiometric defects. Next, finally, impurity defects. Okay, so point defect, three types are there. And here coming to stoichiometric defects. So stoichiometric defects are important defects. Okay, so coming to stoichiometric defects, which are point defects. Okay, so stoichiometric defects, point defects, which are also called as vacancy defects. Okay, vacancy due at a lattice point. So stoichiometric defect again in two types. One is Schottky defect and another one is Frenkel defect. So Schottky defect and Frenkel defect. So stoichiometric defect that comes under point defect. So it is in two types. Two types of stoichiometric defect. So under that, first one, I'll explain first one. Okay, Schottky defect. Schottky defect. And second one is Frenkel defect. Okay, so first coming to Schottky defect. So Schottky defect, this is a point defect, and this is also called as vacancy defect. Why? Because Schottky defect arises due to the vacancy of cation from its lattice point along with vacancy of anions, equal number of anions. Okay, for example, this is a crystalline solid. Okay, so this is a crystalline solid. So Schottky defect, it arises due to the missing of cation from its lattice point. So due to the missing of cation, here a vacancy is created. This is called cation vacancy. Okay, so to balance the charges, to make the crystal neutral, immediately one anion also gets escaped out from the crystal. Okay, so to maintain the neutrality, anion also escaped out from its lattice point. So one more vacancy is created, which is called anion vacancy. Okay, so here Schottky defect is called vacancy defect. It is arises due to the missing of cation from its lattice point, and also with followed by missing of anion. Okay, so number of cation vacancies are equal to number of anion vacancy. This is to maintain the neutrality in the crystal. Okay, so this is Schottky defect. And Schottky defect generally arises with crystals having high coordination number. Okay, crystals with the high coordination number shows this type of defect.